Hey everyone, so we're starting a series of a much anticipated topic, that is electrolysis. First, we'll understand that electro comes from electricity, which means flow of charges, and lysis means breakdown, like hydrolysis is also a word, which again means breakdown. So electrolysis is the decomposition means breakdown. So electrolysis is the decomposition of a liquid ionic compound by the passage of electric current. So there are many important words over here. So what happens is that it's the decomposition. So first thing is decomposition. We have ions in the beginning of electrolysis, but then we convert them into the atoms. So we kind of separate the ions. It works only for liquid substances. So liquid means molten, you have molten dose, or it could be the aqueous solution, so dissolved. And it has to be ionic in nature, so it has to have oppositely charged ions. The positive cations and the negative anions should be there. And it is also really important that metals do not electrolyze. Metals do conduct electricity. We know that. Because metals have a metallic lattice with mobile electrons. But metals do not have oppositely charged ions. They do not have a cation and an anion. So metals will conduct electricity but will not be electrolyzed. Because they don't have oppositely charged ions, they have mobile electrons. When we talk about electrolyte, which is the solution, or you can say the molten substance, it's the molten ionic substance, I should say, which can be electrolyzed. So it's a solution or molten ionic substance containing mobile ions. So mobile ions is really important, and not just ions. It has to have both cations and anions. An electrolyte could be strong or weak electrolyte. Strong electrolyte conducts electricity better. So they are solutions of fully soluble salts, or they could be the aqueous solutions of strong acids like sulfuric, like nitric, which completely dissociate in water to produce ions. Weak electrolytes, on the other hand, are solution of weak acids. Remember, weak acids are the one which are organic carboxylic acids. So they are solutions of weak acids. They conduct electricity but not as better. Imagine we have two beakers with solutions in those, and we have two metal conducting rods which are conducted through a wire, and there are two bulbs, one with each. The bulb will light really brightly if the solution of the electrolyte in the beaker is a strong electrolyte, like sulfuric acid, like nitric acid, like sodium chloride solution or sodium hydroxide aqueous solution, because they are strong electrolytes. But the bulb will light really dim if the electrolyte is a weak electrolyte, like a weak acid solution of ethanoic acid or propanoic acid, etc. So right now, we know what electrolyte is and the basic idea of electrolysis. Let's jump to the requirements and the basic process of electrolysis, so we know what's there, what we need and stuff. So when we talk about electrolysis, first we need a container, which is the electrolytic cell. We need two conductors, which are known as the electrodes. They are both connected with a wire and a battery. So it's generally copper wire and a battery, which has obviously positive and negative terminal. One of the most important thing is the solution or the molten electrolyte. Just talking about the molecular level of the electrode, imagine the electrode is made up of graphite, which is a conducting material. Remember, graphite has layers of hexagonal rings. So I'm just zooming on the graphite electrode, which conducts electricity because it has mobile electrons. So electrode can have graphite in it, which has mobile electrons on it, and these electrons are delocalized. So the electrode can be a conducting material and it can have mobile electrons, and that is why it conducts electricity. The mobile electrons will move and conduct electricity. The electrode can have platinum in it, but we are not talking about it right now. So we have a graphite electrode. Imagine both the electrodes are made up of graphite. Imagine the electrolyte was molten NaCl, which has sodium ions with a positive charge and chloride ions with a negative charge. Now on the basis of the terminal of the battery, there are two kinds of electrodes. The positive electrode connected with the positive terminal is known as anode, and the electrode connected with the negative terminal of the battery is known as the negative electrode or the cathode. So we have anode on the left side of the diagram, which is connected to the positive terminal, and there is a negative electrode connected with the negative terminal. Obviously it's a cathode. All the positive cations, all the sodium ions will go to the cathode, while the chlorides will go towards the anode, because obviously attraction. When the sodium ions go towards the cathode, the sodium ions will gain electrons because they are positive in nature. They gain electron to become a neutral sodium atom. Because they had electron deficiency, now they gain electrons, that is reduction. The chloride ions, on the other hand, will go towards the anode. Chloride ions will lose electrons because they already have extra electrons, so they will lose electrons and become chlorine atom. A chlorine atom is not stable, so actually two chloride ions will lose 2 electrons and become a chlorine molecule, which is gas in nature. So 2 chloride ions are losing 1 electron each and they are becoming chlorine gas molecule. When the sodium is reduced, you will see sodium being collected on the cathode, which is gray metal. So sodium is collected on the cathode as a product. These are sodium atoms because they have gained electrons. So you will receive sodium metal on the cathode, and chlorine will be evolving from the anode because chlorine molecules are pale green in color. So chlorine fumes, pale green fumes, will be received on the anode because Cl2 molecules are pale green in color. So what's the product? It's chlorine gas. And what is the observation? It is pale green fumes evolving. Let's study the idea on a very molecular level. Imagine you have the sodium ions and the chloride ions in the diagram. The electrodes are made up of graphite. And remember there are two kinds of electrodes, the anode and the cathode. I am showing you the hexagonal rings of the graphite for it to be on a molecular level. The cathode is the negative terminal, so it has a lot of extra electrons. The sodium ions will be attracted towards the cathode and the chloride ions will be attracted towards the anode. The chloride ions will lose their electrons and become simple atoms, while the sodium ions will gain electrons on the cathode to become normal sodium atoms. Sodium atoms will be received on the cathode, and Cl2 molecules, which are diatomic molecules, will be received on anode. So chloride ions lose 2 electrons and become chlorine molecule. Chlorine is the product over here, which is pale green in color. We should remember also the idea that losing electron is called oxidation. So at anode, oxidation happens, while at the cathode, reduction happens. So sodium ions will gain electrons and become sodium atoms. That is called reduction. So sodium is the product on the cathode. Product is sodium, not sodium ions, so remember that. It is reduction, and on anode it's oxidation. Oxidation because electrons come on the right hand side, so it's oxidation in the chloride equation. And in the cathode equation, if electrons are on the left hand side, that is called reduction, which means the gain of electrons. Let's study a similar cell over here, which over here we have the molten lead bromide as the electrolyte. So we have changed the electrolyte to study a new case. It has a chemical formula of PbBr2, which is in liquid state. So I have got lead ions with a blue color and bromide ions with an orange color. Remember, bromides are negative in nature, so they will go towards the anode, and leads will go to the cathode. Lead ions have a +2 charge. They gain 2 electrons and become lead atom. Lead ions were positive in nature, cations, and they become lead by the reduction process. When we talk about bromide ions will go to the anode, where they will lose electron and become bromine atom. But a bromine atom never exists alone. So 2 bromide ions will lose 1 electron each, and they will become a Br2 molecule. I should write the 2 over here. So Br2 gas. On the cathode, you will receive lead atoms, which are silver in color. So you will receive silver metal, which is lead. And on the anode, you will receive brown fumes of bromine gas. So the products are lead and bromine gas. Let's label it that on the cathode you're receiving lead metal, which is gray in color. It is going to deposit over here. And on the anode you're receiving brown fumes of bromine gas. So these are the products over there. At anode oxidation happens, at cathode reduction. I hope it's clear for us, and in the coming video we'll be talking more about different kind of aqueous electrolyte electrolysis. So stay tuned guys. Thanks.